Okay, this is going to be the second set of notes from Unit 0. It's properties of real numbers. We're going to go over quite a few properties. Again, if you can, you're going to go ahead and print out these notes so that way you can follow along with me. It's double-sided. If you can't print them out, you're going to have to write them all out. Okay, so here we go. So today we're going over properties of real numbers. As we're doing this, we're going to go ahead and show you some examples on what this looks like. All right. So let's go over the definition. The first property we're going to talk about is distributed property. Um, Distributed property is multiplying the sum of two or more add-ins by a number. Will give the same result as multiplying each add-in individually. By the number and then adding the products together. So for each one of these properties, we're going to give you a general form and then a more specific form of it. So we're going to be doing two examples each time. Let's do the general form first. So here's an example. Let's say I want to multiply A times B plus C. If I were to use distributive property, what I would end up doing is I would take that A and I would distribute it to the B and then distribute it to the C. If I were to highlight it, let me go ahead and do that right now. If I wanted to highlight it, I would take the A right here. Sorry, my stuff wasn't working well. There you go. I would take that A, multiply it by the B, multiply it by the C. Okay. And I'm going to go ahead and highlight the word distributive property because that's what we're going over right now. I would distribute the A to the B, and I would distribute the A to the C. If you did that, you would end up with something like this. A times B is AB, plus A times C is AC. And again, what I did right here was I distributed the A. All right, so that's distributive property. Let's go ahead and show you what that looks like in a specific example. So if I had something that looked like this, 3 times 5 plus 4, then again, distributive property says I would distribute the 3. So then I'm multiplying 3 times 5 and I'm multiplying 3 times 4. If I were to use my arrows to kind of point that out, it would look like this. I would highlight the 3, and that 3 is going to go to the 5, and the 3 is going to go to the 4. So I need to multiply those things together. That would result in me getting 3 times 5 plus 3 times 4. And let's just go ahead and verify that this is in fact going to work. Okay. For example, if I were to do it on the left-hand side, first I would add the 5 plus 4, and that would give me 9. And then I would multiply it by 3. 9 times 3 gives me a 27. So just keep that 27 kind of locked in the back of your head. Let's look at the right-hand side. Let's see what happens there. Here, I would go 3 times 5, which gives me a 15. And then a 3 times 4, which gives me a 12. That is a 15 plus a 12. And again, what I end up with is 27. So both sides are in fact the same. And it proves that distributed property will in fact be equal when you distribute the number in front of the parentheses. All right, let's move on to the next one. Next one we're going to do is commutative property. I'm going to go ahead and highlight my vocabulary word. And let's take a look at what commutative property says. It says the commutative property states that the numbers on which we operate can be moved or swapped. From their position without making any difference to the answer. So again, just like last time, we're going to go ahead and give you a general way of doing the problem. Then we're going to give you a really specific one. So let's go ahead and split this up. Let's give you the general form first. For commutative property, the general example is going to look like this. We're going to say A plus B. And again, commutative property says I can swap the two things and it's not going to change the answer. So A plus B must be the exact same thing as B plus A. All we did was we changed the order of the numbers. To prove that that works, let's go ahead and give you a real world example. So I can say if I had something like 3 plus 5, that must be the exact same thing as 5 plus 3. Well, let's see. 3 plus 5 is 8, and 5 plus 3 is 8. And sure enough, those two are exactly the same. The same works for commutative property of multiplication. So let's give you the general form. If I were to multiply two numbers and I don't know what the numbers are, I would write that A times B must be the exact same thing as B times A. Let's just show you that it works. Again, we're going to use the 3 and the 5. So if I say 3 times 5, that must be the exact same thing as 5 times 3. And let's just verify. 3 times 5 is 15. 5 times 3 is also 15. So sure enough, both of those things work. As far as what I'm going to do to highlight this property, so it kind of stands out for me, I'm just going to say commutative property is the property in which we switch these two numbers together. So I'm going to go ahead and draw arrows here. We just switch the numbers. The order of the numbers changes. Instead of A and B, it changes to B and A. Instead of 3 and 5, it changes to 5 and 3. Same thing with the multiplication. Instead of the A and B, it changes to B and A. Instead of 3 and 5, it changes to 5 and 3. So when you're trying to figure out what kind of property it is, my suggestion would be first check, do the numbers themselves switch? If the numbers themselves switch, chances are it's going to be commutative property. All right, we're going to move on to the next one, which I think is the toughest one, and that one is associative property. Associative property is the definition says the associative property is defined as when more than two numbers are added or multiplied, the result remains the same, irrespective of how they are grouped. Let's go ahead and give you the general examples and the specific examples. So we're going to need a little bit of space of this here. I'm going to go ahead and write a little bit smaller here. We are going to have to write quite a bit. So this one says if you have A plus B plus C with parentheses around the A and the B, that's got to be the same thing as A plus B plus C with parentheses around the B plus C. Notice that the order of the numbers did not change. It still says A, B, and C on the left, and it says A, B, and C on the right. What did change was the placement of the parentheses. So let's give you a real example. We're going to say if I have 3 plus 4 plus 5 with parentheses around the 3 and the 4, that must be the exact same thing as, again, the numbers are going to stay in the same spot, 3 plus 4 plus 5, but my parentheses are the thing that's going to switch. It's going to move to the end. If I were to do this in the correct order on the left, I got to do the parentheses for first. 3 plus 4 is 7. 7 plus 5 is 12. 12, 12, 12. Keep that 12 in your head. Let's take a look at the right side. On the right side, I should be doing the 4 plus 5 first. That's a 9. And then 3 plus 9 is 12. So again, you had 12 on the left, 12 on the right, and they must be exactly the same. Okay, what about associative property for multiplication? It's going to be pretty much the same thing. You're still going to be dealing with three separate things except for multiplying. So I'm going to write A times B times C. This time the parentheses around the A and the B. And remember, on associative property, the order of the numbers do not change, but the parentheses does. So we're going to go ahead and write A times B times C, except this time the parentheses are going to be around the B and the C. Using real world examples, we're going to go ahead and write 3 times 4 times 5 with parentheses around the 3 and the 4 is equal to 3 times 4 times 5 with parentheses around the 4 and the 5. Again, the order of the numbers stay the same. The parentheses is what switches. And just as a check, on the left side, it should say 3 times 4, which is 12, times 5 is 60. On the right side, we're going to do the 4 times 5 first. That's 20 times 3 is also 60. So we verified that these properties, in fact, do work. We're going to go ahead and highlight now stuff that will make this pop so that I know what this means. Let me go ahead and use my pink highlighter. Associative property is pretty much when the numbers stay the same, but the parentheses is what switches. So we're going to go ahead and put emphasis on those parentheses to let us know that's the thing we should be focused on when we're talking about associative property is, are the numbers staying the same, but the parentheses, the thing that's being switched. I just realized I forgot this. Okay, so that takes care of that. The next properties are not that difficult. I think, like I said, associative property is probably the toughest one. I like identity property because identity talks about your identity or the number's identity. Identity means like who you are, right? So, like, for example, my identity is who I am. If the identity of a three is a three, which means the three is not going to change. So, identity property makes it so that the number stays who it is. So if I'm going to be adding something, like let's say to 3, if I take 3, what number would I have to add to it so that the identity stays the same, so that I still end up with a 3? Well, the only way for me to add 3 to something and still have an answer be 3 is for me to add 0. So we're going to go ahead and write that adding 0 to any number results in the number itself. So again, let's say I have a random number and I'm not going to tell you what it is. So I'm going to go ahead and call it A. What do I need to add to A in order for it to stay the same and keep its identity? Well, if I want to add A plus something and get the answer of A, I must be adding 0. And the example we used earlier, 3 plus what number is going to make that 3 keep its identity of 3? Well, you better be adding 0. So whenever you add 0 to a number, you're using the additive identity. So that way it keeps its same value, keeps its identity. Okay. Same concept on the right-hand side as far as multiplicative identity. I want to take a number and multiply. So like, let's say I take 7. I want to multiply it by a number so that it keeps its identity. It still stays a 7. Well, for multiplication, any number multiplied by 1 results in the number itself. Because when you multiply a number by 1, it stays the same. So as far as the general example for this one, we're going to go A times 1 is equal to A. It stays the same. And the example I use, if I take 7 and I multiply it by 1, guess what? It's still going to stay a 7. It's going to keep its identity. And that takes care of the identity property. What are we going to do to highlight this to make it pop? We're going to go ahead and first highlight the vocabulary word, which in this case is identity property. I'm starting to run out of colors, so I'm going to start using some of the old colors. I'm going to go ahead and use this orange. And identity property for adding the 0 is what's important. We're going to be adding that 0, adding that 0. Identity property for multiplication, what makes this important is when you multiply by 1 and when you multiply by 1. All right, that takes care of identity property. We got one more property to go, and that'll take care of all the properties that we're going to be focusing on this lesson. All right, so the last one is inverse property. Inverse property states when we add a real number and its opposite together, the result is. When I say opposite, like for example, the opposite of 4 is negative 4. What happens when I add a 4 and a negative 4? Well, I get 0. So that's exactly what's going to happen here. Oops. Just realized I have the wrong button. Let me go ahead and switch that out. What's the opposite of 6? It's negative 6. When I add 6 and negative 6, the answer is 0. The opposite of negative 2 is 2. When I add negative 2 plus 2, the answer is still 0. So whenever you add opposites together, or it's inverse, then we get 0 as an answer. As far as the general example, that would be A plus negative A. When I add its opposite, the answer is going to be 0. And we did a bunch of examples earlier. Let's go ahead and go 4 plus negative 4. And the answer is going to be 0. All right, as far as the multiplicative inverse, this one's a little bit tougher. It says when we multiply any non-zero real number and its reciprocal together, the result we get. First of all, some of us forget what this reciprocal means. That means you take your fraction, whatever it is, and you flip it. Okay. Sorry about that. So, for example, let's do some little mini examples. If I have the fraction 2/3, then the reciprocal of 2/3 is 3/2 because all you do is flip the fraction. If you have the example of -5/3, and I take the reciprocal, that's going to change to a 3/5. All we're doing is flipping it. Let's do a weird one. If I have the number of 4, now 4 is not a fraction, so it's hard to flip it, right? It's hard to take the reciprocal. So all you have to do with that 4 is make it a fraction first. How do you make 4 into a fraction? Is you put it over 1. Now it's easy to flip this or to get the reciprocal. We're just going to flip it, and it's 1/4. That is to say the reciprocal of 4 is 1/4. All right, what happens when you multiply reciprocals together? The result is going to be the number 1. So let's see. If I take my general example, if I take A and I multiply it by reciprocal, remember, you make it A/1, you flip it, you end up with 1/A. The answer you get is going to be 1. If you take 2/3 and you multiply it by its reciprocal, 3/2, that's going to be a 6/6, which again, the answer is going to be 1. Okay, so that takes care of the properties. Oops, I forgot to highlight. Let's go ahead and do that right now. I'm going to go ahead and use pink. Inverse property. For this one, we're going to be adding the opposite. This is the opposite, and the -4 is the opposite. As far as for multiplying, we're going to multiply the reciprocal, which again means to flip. That's why we flip that to 1/A, and that's why we flip that to 3/2. Okay, that takes care of the front side. Let's move on to the back. Back side, we're going to speed run this a little bit, and we're going to show you how I think of these problems. There is a really, really, really tricky one, but I'm going to try to do my best to explain my way through that tricky one for you. Okay. We're going to try to match up those answers and see which property it is from the previous page that we're using. The first one says 9 plus 4 plus 11 is equal to 9 plus 4 plus 11. The first thing I want you to notice is the order of the numbers did not change. It's still 9, 4, 11, 9, 4, 11. That means it is not commutative property. Commutative property is when your numbers switch. So then what's different about these ones? Well, the parentheses is the thing that changed. It was on the right, now it's on the left. That's definitely associative property. And since we're adding, then that's got to be associative property of addition. Number 1 must be letter C. On number 2, it started as an 8. I added 0 and it stayed an 8. It looks like it kept its identity. And because it's adding, that must be additive identity. That's going to be letter E. Number 3 is the trickiest one. The trickiest one. So be careful because I know you guys are looking at the parentheses, but that's not the way I want you to do this. Remember, I told you the first thing you need to do is decide if those numbers switch. So take a look at the numbers. I got 9, 4, and 11, and it changed to 4, 11, and 9. Did the numbers switch? If the answer is yes, that's automatically commutative property. And because I'm adding, this is commutative property of addition. Very, very tricky. I understand if you would think it's associative property because you see the parentheses move, but first, you got to check if the numbers move. So we're going to say that this is a commutative property of addition. Next one, 17 times 30, 30 times 17. The numbers definitely switched, automatically commutative property. And because we're multiplying, that's going to be commutative property of multiplication. I'm going to take 19, multiply it by 1, and the answer is still 19. That sounds like an identity. It's data 19. And we're multiplying, so that should be letter F. On number 6, y plus xz is equal to xz plus y. Did the numbers switch? I got yxz and xzy. They definitely did. So I know this is commutative property. And it looks like what switched was the adding part of it. So I was adding the y plus xz. and then it changed to xz plus y. So I'm going to go ahead and say that that's commutative property of addition, letter A. On number 7, it's 2 times 3 times 4 is equal to 2 times 3 times 4. Right away, we ask ourselves, did the number switch? 2, 3, 4, 2, 3, 4. The answer is no. They did not switch, so it's not commutative property. What did change, though, was a parentheses. So therefore, this must be associative property. And all I'm doing is multiplying, so this should be letter D, associative property of multiplication. Number 8, ST plus V is equal to TS plus V. Did the order switch? It sure did. So I know it's commutative property. Now the question is, did the adding switch or did the multiplication switch? If you notice on the multiplication here, it's multiplying ST and here it's multiplying TS. So the multiplication is what switched. We're going to go ahead and write commutative property of multiplication, letter B. I can even kind of understand if it was letter A because it looks like you switched the adding as well. So I guess it might be both. Number 9, negative 4 plus 0 is equal to negative 4. It looks like the negative 4 stayed a negative 4, so that's an additive identity because you're adding. This is letter E. And then the last one, 80 times 9 is equal to 9 times 80. The numbers definitely switch, and we're multiplying. That's commutative property of multiplication, letter B. All right, guys, 3 more examples, and we will be done. It says, Miss Collins is going shopping. She needs to buy a new bottle of shampoo for $4, a bag of dog food for $26, and a book for the beach for $14. Show 2 different methods to figure out her total using the associative method. The best way I like to think of this is like her going to 2 different stores. The first time she goes to the store, she's going to buy 2 items and then buy the last item at the second store. So on the first store, she's going to buy the shampoo for $4 plus the dog food for $26. That's at store number 1. Then she's going to go to the second store and finally buy the book. If I were to solve this, right, you got to do parentheses for it first. So 4 plus 26, that is 30. And then 30 plus 14 is $44 is what she spent. The second way of doing this is to think that she only bought 1 item at the first store and 2 items at the second store. So at the first store, she only spent $4 plus. But at the second store, she bought 2 items. So we're going to put that one in parentheses. And over there, she bought $26 worth of dog food and $14 for the book. Let's see. We should do parentheses first. I know that 26 plus 14 is 40. So I got 4 plus 40. And then 4 plus 40, I get 44. And oh, look at that. It's the exact same thing both ways. Associative property works for this problem. Example 3, it says use mental math to simplify each expression. I got written down twice, so we're going to skip that. Think about how to best group the numbers to simplify. So when I look at these numbers, you see how it says 98 plus 3? That's 101. That's not a nice number, so let me not do that. But if I go 98 plus 2, that's 100, and that's much nicer. So let me go ahead and do that. Let's add 98 plus 2 first, and then we're going to add the 3. If I add 98 plus 2 first, that's going to be 100 plus 3. And I know that's 103. All right, let's try letter B. If I do 20 times 16, oh, you know what? I do know that answer, but it's kind of tough, right? Like that's not the easiest thing to do. However, if I go 20 times 5, I know some of you guys know this answer. 20 times 5 is a nice number. It's 100. 20 times 5 is 100. So if you didn't know that, it takes 5 $20 bills in order for you to have $100. And 100 times 16, this is something that we did in class the other day. In order to multiply by 100, all you have to do is move the decimal 2 times to the right on the 16. So I would take this 16, move the decimal 2 times to the right. Looks like I have 2 gaps. That gives me 1,600 as my final answer. So that's crazy that we could do 20 times 16 times 5 in our heads and not need to do too much with it, right? Like not needing to write it down. I know I'm writing it down just so you can kind of see what I'm thinking in my head, okay? And then the last one is it's kind of a tough one. It says, suppose you buy snacks costing 45 cents, 65 cents, and $1.55. Use mental math to try to find the cost of the snacks. And again, we're going to try to think of the best way of grouping this. So really what I'm going to do is I'm going to add up these numbers. I know I'm adding 45 cents plus 65 cents. Sorry, I should wrote that wrong. Let me write plus 65 cents plus $1.55. If I were to add 45 cents with 65 cents, that's $1.10, and that's hard to work with, so I'm not going to do that one. Instead, I'm going to add the 45 cents with the $1.55 because I know that gives me $2. That's like a really nice number. And then once I get those $2, I just need to add the extra 65 cents back. So again, we just said that these two add up to $2. And when I add 65 cents to that, that's going to give me $2.65. All right, those are all the notes for today. At the end, it should look like this. Remember, you're going to take this, you're going to put it in your 3-ring binder, and this is going to be the second set of notes for your binder. All right, as always, if you have any questions, feel free to ask or email me.